Okay, so 5.3, we're going to be looking at the graphs of rational functions that are in this form, ax plus b over cx plus d. Now, before we go on, I want to understand what rational functions are. A polynomial function is any function within which you have an expression with one variable, positive integers as exponents, and they are all being added or subtracted together with the denominator of 1. A rational function is any function where there is a variable in the denominator. So, for example, 3x minus 5 over x plus 2. So today we're going to be looking at how to graph functions that have variables in the denominator. And for the most part, we'll be sticking to polynomial functions in the numerator and the denominator. So determine how the graph of, we'll start with the first example. Determine how the graph of f at x approaches its vertical asymptote. So in this question, we're going to be looking at, one, being able to identify what is the vertical asymptote, and two, what is happening around the vertical asymptote. Is it going to be approaching the vertical asymptote and going to positive infinity or going to negative infinity on either side? So the first thing we're going to do is identify the vertical asymptote. The vertical asymptote is wherever the denominator is equal to 0. In this case, negative 2. So the vertical asymptote will be at x equals negative 2. What this means for us is that at negative 2, we will have an asymptote. What I don't know now is the asymptote going to create a function that goes like this, or this, or this way, or this way. I know that on either side, my function is going to approach the vertical asymptote without ever touching it. What I don't know is if it's going to go up or down. It's going to go down or up. And that's what we need. That's what the question is asking us to determine. To figure that out, the easiest thing to do is to check a number immediately to the left or to the right of my function. So if I take one number to the left and one number to the right, left of negative 2, I get negative 2.1. And to the right of negative 2, I will get negative 1.9. And what I'm going to do is plug those values in to this function to find out what we get. So f of negative 2.1 will be 3 times negative 2.1 minus 5 plus 2. What we get? Negative 6.3 minus 5 over negative 0.1. This will be negative 11.3 over negative 0.1, and that will quickly become positive 113. Now I do the same thing on the opposite side. F of negative 1.9 will be 3 times negative, minus 5 over negative 1.9 plus 2. This time the denominator will be positive 0.1. The numerator will be negative 1.9 multiplied by 3. That's 3.8 for 5.7. So negative 5.7 minus 5, negative, is that right? 3.8, 4, yep. So negative 10.5 over 0.1 will be negative 105. What does this show me? At negative 2.1, meaning to the left of my asymptote, I have a positive number. To the right of my asymptote, I have a negative number. So my graph, when I draw it at the asymptote, at negative 2, to the left will be a positive number, meaning it will approach positive infinity. And to the right, it's a negative number, so it will approach negative infinity. This question was just focused in on what happens at the vertical asymptote. Let's see what the next question. For the next ones, let's look at how would we graph these functions. We're going to take whatever piece of information that we have. So first thing we know here is that the vertical asymptote will be at x minus 3 cannot equal 0, so it's equal to 0 because that's the vertical asymptote. So at x equals 3, we have our vertical asymptote. Now, the only other piece of information that we need is what's happening around it. Before we get into that, I do want to look at our horizontal asymptote. This is now where we recognize if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is automatically at 0. So the x-axis is automatically the horizontal asymptote. So again, the degree of the numerator is less than the degree of the denominator. This is the degree of 0, this is the degree of 1, therefore the horizontal asymptote will be the x-axis. The only thing that's left now is to figure out which quadrants my graphs will be in. So I'll take a number to the right of 3. So if I was to plug in 3.1, this would be 2 over 3.1 minus 3. So it's 2 over 0.1, which means it would be a positive number. This is what the graph would look like. Now to the left of it, I still need to determine whether it will be at the top or at the bottom. So I can plug in a number to the left of 3. So I can plug in 2.9. 2.9 minus 3 will be a negative number, and the 2 is still positive. So this is what my function would look like. Positive to the right, negative to the left. Now let's look at number 3. Same idea, we need to identify what we know. We know there's a vertical asymptote at 3x plus 4 equals 0. So x will equal negative 4 over 3. But now we look at what's happening with the numerator and the denominator. In this example, we saw that if the degree of the numerator is less than the degree of the denominator, then you have a horizontal asymptote that's on the x-axis. Now we have a degree that is equal in the numerator and the denominator. This is degree 1, this is degree 1. If the degrees of the numerator and the denominator are equal, the horizontal asymptote will be at the coefficients. If you were to divide the coefficients of the leading coefficient, the horizontal asymptote, if the degrees are equal, will be the quotient of the leading coefficients. So x and x are the leading degrees because that's the highest degree. So I would take the the coefficient of x, which is 1, and the coefficient of 3x, which is 3. So the horizontal asymptote will be at x equals 3. And because it's horizontal, it'd be y equals 1 over 3. Let's graph it. So we know that there is a vertical asymptote at x equals negative 4 over 3. And I'm just going to estimate that for now. We have a horizontal asymptote at y equals positive 1 over 3. So just positive 1 over 3. We have our vertical and horizontal asymptotes. There's one more piece of information that we always can get. We can always get the x-intercepts and the y-intercept. The x-intercept is whatever makes the top into 0. So to find the x-intercept, I would set the numerator equal to 0, and I know that x equals 2 is the x-intercept. So this is 0, there's x equals 2, I know the graph has to go through there. The y-intercept, I can get that by setting x equal to 0. So if x is 0 and x is 0, these two terms would cancel out, and it's just negative 2 over 4. So the y-intercept is negative a half. Based on that, I can figure out that my graph would have to be in the negative section here. So it will go up and continue onwards. It's a bad curve because it looks like it's curving back. And if it's in this corner, down here, we can check to the left of negative 4 over 3 by plugging in, for example, negative 2. Negative 2 minus 2 is negative 4, and negative 6 plus 4 will still be negative, which means I have negative divided by negative to get a positive number. And that is what this function would look like. What are the key factors to understanding here? Horizontal asymptotes. If the degree of the numerator is less than the degree of the denominator, you will have the horizontal asymptote at 0. So that's the x-axis itself. If the degree of the numerator is equal to the degree of the denominator, you would just divide the leading coefficients to figure out where the horizontal asymptote would be. In this case, x over 3x would be 1 over 3.